Okay, so get ready because we're going deep on the scale of the universe this time.
Yeah, it's going to be a wild ride.
You guys send in some really cool stuff, and I got to admit, after looking at all this, I am feeling pretty small.
I think that's kind of the point, right?
Yeah, I guess it is, but in a
Yeah.
good way. It's like it just kind of puts things in perspective.
Definitely.
So let's start small, I guess, with something everybody knows: the Earth and the Moon.
Yeah.
So we all know the Moon is like what, almost 400,000 kilometers away, 384,400 kilometers to be exact. But sometimes it feels closer, doesn't it?
You know, it's funny you say that because, I was thinking about that the other day. In our minds, it doesn't feel that far. But if you think about it, if you tried to drive to the moon,
Oh wow.
even if you could, just drive straight up at 100 kilometers an hour,
Yeah.
it would take you, 160 days to get there.
160 days in a car.
Yeah. That's more than 5 months nonstop.
No thanks. That'd be a fly.
Yeah.
But speaking of go to the moon, we did do that. Humans walked on the moon.
Yeah. It's crazy to think about, right?
Like, it still blows my mind that we figured out how to do that.
Totally. I mean, it's one of the greatest achievements in human history, right?
Absolutely. 12 people walked on the moon.
During the Apollo missions.
Yeah.
And I don't know if you've ever seen those pictures of the Earth from the moon.
Oh, yeah.
It's this tiny blue sphere hanging in space. It really makes you realize just how small and fragile our planet is.
Right. It's like that famous pale blue dot photo taken by Voyager 1.
Oh, yeah.
Earth is just a pixel.
Yeah.
And Carl Sagan said it best. That's here. That's home. That's us. This
Ah,
gives me chills.
Such a powerful statement.
And speaking of Voyager 1, that thing is still out there, isn't it?
Yeah.
How far away is it now?
It's about 138 AU from Earth.
AU. Remind me what that means again?
Oh, yeah. So AU stands for astronomical unit, and it's the average distance between the Earth and the sun.
Okay.
So basically, Voyager 1 is 138 times farther from us than the sun is.
Yeah.
And keep in mind, it takes light more than 8 minutes to travel from the sun to Earth.
8 minutes.
Yeah.
So, if the sun just disappeared right now, we wouldn't even know for 8 minutes.
Exactly.
That is kind of freaky.
Yeah, it is. It's hard to wrap your head around that, right?
Yeah. And you're saying light travels how fast?
About 300,000 kilometers per second.
That's fast.
It is. It's fast enough to circle the Earth 7.5 times in 1 second.
Wow. Okay. Yeah, that is fast.
Yeah, but even at that speed, it takes light a really long time to get across the universe.
Right.
So when we start talking about those really big distances beyond our solar system, we need a bigger unit of measurement.
Okay. So what do we use?
The light year.
The light year. Okay, tell me about that.
So a light year is just the distance that light travels in 1 year,
Yeah.
which is about 9.5 trillion kilometers.
9.5 trillion kilometers.
Yeah. So to put that into perspective, if we could travel at the speed of light, it would still take us over 4 years to reach the nearest star to our sun.
4 years at the speed of light?
Yeah. It's Proxima Centauri.
That's the closest star.
It is.
So all those stars we see up there in the sky,
Yeah.
some of that light has been traveling for a long time.
It has. Yeah. Sometimes even for centuries.
Wow. It's kind of like looking back in time, isn't it?
It is. We're seeing them as they were in the past.
Yeah.
Some of that starlight could be millions of years old.
Millions of years old.
Mm-hmm.
Okay, that is mind-blowing.
And remember, our sun is just one star out of hundreds of billions of stars in our galaxy, the Milky Way.
Right, the Milky Way. It's like a
Yes.
giant city of stars, and we're just this little neighborhood.
Yeah, exactly. And to continue that analogy, imagine our galaxy as a city that spans 100,000 light years across.
100,000 light years.
That means even if we could travel at the speed of light, it would take us 100,000 years to cross it.
100,000 years.
Yeah, that's just how big it is.
That's just our galaxy, right?
It is.
And that's just like what we can see
Yeah,
with our naked eyes.
yeah. It's just a fraction of all the stars out there in the Milky Way.
And to think that's not even the whole story, right?
Oh, no, not even close.
Our galaxy isn't alone. It's part of a group of galaxies.
It is. It's called the local group.
A group of galaxies. There's more than one.
Oh, yeah, way more. The local group is a collection of about 54 galaxies, all held together by gravity.
Okay, so there's our galaxy
Yep.
and 53 other galaxies just hanging out together.
Pretty much. And that whole group spans about 10 million light years.
10 million light years. I'm starting to feel really small.
Yeah,
It's-
that's hard to even imagine, right?
It's like, yeah, I'm an ant in a giant park or something.
It's definitely a humbling experience.
Yeah, but wait a minute.
Yeah.
The local group,
Uh-huh.
it's not even the biggest thing out there, is it?
No, it's not.
There's something even bigger.
Yeah, it's called the Virgo supercluster.
Okay.
And that's where we'll pick up in part 2 of our deep dive.
Oh, man, my brain needs a break.
We'll see you then.
All right, so last time we were talking about galaxy groups, and you were about to tell me about something called the Virgo supercluster.
Right, the Virgo supercluster.
And this thing is even bigger than the local group, which already has like 54 galaxies in it.
Way bigger. It's huge.
Okay, so how big are we talking here?
So the Virgo supercluster has at least 100 galaxy groups and clusters, just like our local group.
Wait, so the local group with its 54 galaxies,
Yeah.
it's just a small part of this Virgo supercluster.
Exactly. And the Virgo supercluster itself spans 110 million light years.
110 million light years. I mean, at this point, are we even talking about time as we understand it?
Yeah. It's hard to even comprehend, right?
110 million years.
If we could travel at the speed of light, it would take us 110 million years to cross it.
I can't even imagine.
And here's the thing.
What's that?
The Virgo supercluster is just a tiny part of an even bigger structure.
Seriously, we're still going bigger.
Oh, yeah.
I thought the Virgo supercluster was the top of the cosmic ladder.
Nope. There's always something bigger in the universe.
Okay, so what's bigger than the Virgo supercluster?
This one is called the Laniakea supercluster.
Laniakea. That sounds pretty epic.
It is. It's home to about 100,000 galaxies, including our own Milky Way, and it spans 520 million light years.
520 million? That's like 5 times bigger than the Virgo supercluster.
Yeah. It's hard to even imagine.
My mind is blown. So that means the Virgo supercluster is just like a tiny little neighborhood in this giant Laniakea supercluster.
That's right.
Okay, I need to sit down for a minute.
I take a deep breath.
All right, I think I'm ready for more. So is this it? Is this the biggest thing?
Well, not quite.
There's something even bigger than Laniakea.
Laniakea is just one of many superclusters in the observable universe.
The observable universe, wait, there's more than what we can observe.
The observable universe is everything we can see from Earth right now.
So like there could be stuff out there that we just can't see because the light hasn't reached us yet.
Exactly. The light from objects beyond the observable universe hasn't had enough time to reach us since the Big Bang.
So it's like a cosmic horizon?
It is. It's limited by the speed of light and the age of the universe.
Okay, that makes sense.
Yeah.
But how big is the observable universe?
It's estimated to be about 93 billion light years in diameter.
93 billion. That number is so big it doesn't even make sense anymore.
Yeah, it's hard to wrap your head around it.
It's like trying to count all the grains of sand on all the beaches on Earth.
It's a lot. And get this, the observable universe might actually just be a tiny fraction of the entire universe.
You're telling me there might be more than what we can observe? That's crazy. What could be out there?
We can only speculate, but there's a theory called cosmic inflation.
Cosmic inflation.
Yeah, it basically says that the universe expanded really, really fast right after the Big Bang, like a super fast growth spurt.
So like it blew up like a balloon?
Kind of. And if cosmic inflation is true, the universe could be way bigger than what we can see, possibly even infinite.
Infinite. So that means there could be an infinite number of galaxies and stars and planets?
It's a possibility.
Wow. I need to take another break.
We'll be back in part 3.
Okay, so we've been on this wild ride through the universe, from the moon to the local group to superclusters and the observable universe. And I have to say my mind is pretty blown.
Yeah, it's a lot to take in.
It really makes you think about, our place in all of this.
It definitely puts things in perspective.
It's amazing to think about how much our understanding of the universe has changed, even in just the last few hundred years.
Right. Like we used to think our solar system was the whole thing.
I know, it's crazy, right? Now we know it's just this tiny little speck in this vast cosmos.
And who knows what we'll discover next.
It's like standing on top of a mountain and looking out at this huge landscape.
Yeah.
It makes you feel so small, but also kind of connected to something much bigger than yourself.
Definitely. It's a powerful feeling.
And it really makes you realize that a lot of our everyday problems are pretty insignificant in the grand scheme of things.
Yeah, it's all about perspective.
When you think about the vastness of space and time, it just puts things in perspective.
The universe has been around for billions of years.
And it'll probably be around for billions more.
Exactly. We're just here for a tiny little blip in time.
It's kind of humbling, isn't it?
It is. But it's also kind of freeing,
Yeah. It makes you appreciate the moment.
Yeah, and it makes you want to make the most of your time here.
And it also makes you think about how everything is connected, right? Like all this stuff in our bodies.
Yeah.
It came from stars.
It did. We
Yeah.
are literally made of stardust.
That's crazy.
Yeah, it's one of the most amazing things about astronomy, I think.
Yeah. It's like We're not just in the universe, we are part of the universe.
And that connection goes beyond just our physical bodies, too.
How so?
Well, like all the energy and matter in the universe, it's all constantly interacting and changing.
So everything is connected.
Everything from the smallest particles to the biggest superclusters.
It's like the universe is this giant web, and we're all just threads in that web.
Exactly. And it makes you think about how our actions can have consequences that ripple out and affect other things.
So even though we might feel small, we still matter.
Absolutely. We're not just passive observers in this universe, we're active participants.
Like, and the more we learn about the universe, the more we realize how much we still don't know.
There's always more to discover.
And with all the new telescopes and technology, we're learning more and more every day.
Yeah, it's really exciting.
I can't wait to see what we discover next.
Me too. It's an amazing time to be an astronomer.
Well, on that note, I think it's time to wrap up our deep dive into the scale of the universe.
Yeah,
It's been quite a journey.
it has.
I'm feeling both inspired and humbled.
Me too.
And to everyone listening out there, remember, the next time you look up at the night sky, don't just see twinkling stars, see the echoes of ancient light, the remnants of exploded stars, and the vast cosmic structures that we've been talking about.
Yeah.
And remember that you are a part of this amazing and ever-evolving universe.
Keep looking up.
Thanks for joining us on this deep dive, and as always, keep exploring